Hey guys, this is Sid from BreVITy, and today we'll be solving a very interesting lead code question, longest substring without repeating characters. So now we're going to implement this using a very popular variation of the two-pointer technique known as sliding window. So in a sliding window kind of problem, you're going to have 2 pointers, the left pointer and the right pointer. So in this scenario, you can call the left pointer I and the right pointer j. So this is a string which we saw in the previous example, and we can initialize the left pointer I to the 0th index and the right pointer I to also to the 0th index, or you can call it the first character of the string. And we can do 2 operations. You can increment the left pointer by 1, or you can increment the right pointer by 1. So the whole concept of sliding window depends on knowing which operation to do when. To know which operation to do when, you need to understand 2 scenarios. The first scenario is growing phase. So growing phase occurs when we increment the right pointer or the j pointer. So consider this example you see here. We increment the j pointer and the j pointer increases by 1. We increment it again. So as you can see here, every time we increment the j pointer, the window keeps increasing. So what is a window? The window is basically any characters between the I and j pointer, and the size of window is j minus I plus 1. Another scenario is shrinking phase. So a shrinking phase happens every time we increment the left pointer or the I pointer. So every time we increment the I pointer, the window gets more and more smaller. This is known as shrinking phase. So the entire problem depends on whether knowing when we have to increase the size of the window, when we have to decrease the size of window. That is the growing and shrinking phase. So now let's try to solve this problem. So this is the string which we saw in the lead code example, and we can initialize both the pointers to the 0th index for now. And currently the window just has the character A in it. So we're going to have an intermediate storage. So what is intermediate storage? So intermediate storage is used here to keep track of each character and number of times it's repeated in the window. So currently a window just has the character A. So it's just A, and the number of times it occurs is just once. And we can have a variable maximum window length so far to keep track of the maximum size of the substrings which we have in the window so far. And so a window just has the character A and is repeated just once. So if it's a valid substring, we have to grow it, because if it's valid, we try to expand it further to increase the size of the substring. If it's not valid, we try to shrink the window to make it into a valid substring. That's the whole concept. And in this case, it's a valid substring, so we grow it. So we grow it by increasing the j pointer. So we increase the j pointer by 1, and new character gets added as b. So the new substring which the window has is ab. And the maximum window length so far is 2, because AB size is 2. And it's valid, so we grow it more, and the new character gets added as C, and the intermediate storage we also add it. C occurs once, and the maximum window length so far is 3, because ABC length of ABC is 3. So ABC is a completely valid substring, so we increase the window size by increasing the j pointer, and the new character which gets added is A. So now we have an issue. A already exists in the window, because the window is ABCA and A already exists. And we don't want any repetition of characters, because that's the entire question about. And to avoid this, we can't grow the window further from now, because if we grow the window by increasing j pointer, new character which gets added is B, and it won't solve the issue because A will still be 2 times in the substring. So only thing which we can do now is shrink the window. So we shrink the window by increasing the I pointer. So we increase the I pointer by 1, and we remove the A from the window. So now the substring is BCA. So BCA is everything between the I and j pointer, and A is repeated once, B is repeated once, C is repeated once. It's perfect. So BCA is a valid substring. So if it's valid, we try to grow it further, and we add the next character B. So the same issue we're going to see here is B is already in the substring, and we just added another B. So we have to shrink it to remove the occurrence of B. So we shrink by increasing the I pointer, and the new substring becomes CAB. So you know the drill, it's a valid substring, and so we try to grow further by increasing the j pointer. So we increase the j pointer, the new character gets added as C. So C already exists in the window, so we have to shrink it to make it into a valid substring. So we increase the I pointer, and the new substring is ABC now. So ABC is a valid substring, so we have to increase the size of we have to increase the size of window. So we increase the j pointer by 1, and the new window becomes ABCB. So ABCB is not a valid because B is repeated twice, as you can see in intermediate storage. So we have to stop it by shrinking the window. So we increase the I pointer by 1, and it doesn't solve. Because the new window is BCB. B is still repeated twice. So we shrink it further by increasing the I pointer by 1 again, and the new window becomes CB. So CB is a completely valid substring, and if it's valid, we have to increase the size of the window. So we increase the j pointer by 1, and the new window becomes CBB. So CBB is not valid because B is repeated twice. So you know the drill. We have to shrink it. So we shrink it by increasing the I pointer, and it's still invalid because B is repeated twice because the new window has the substring BB. So we have to increment I again, and the new string becomes B. So we keep doing it till J reaches the last node in the string. And the complexity, okay, and then we have to return the window length so far, which is 3 as required by the question. So the complexity to solve this is just O of n, because we're just having pointer I and pointer j, and we're just having one pass because j is moving from the first index, 0th index to last index, and I is moving from the 0th index almost till the last index. So it's a completely O of n time complexity solution. Well, with the algorithm now out of the way, it's time to code. You can either code in Java, C++, or Python. Choose wisely.